morning students, welcome to our online video class of chemistry. In previous section we had discussed about vapor pressure of liquid solution and solid liquid solution, also about Raoults law. Today we will discuss about ideal and non-ideal solutions and colligative property.
Ideal solution. An ideal solution is one which obeys Raoults law exactly at all temperature and over the entire range of concentrations. And the ideal solution is formed from components which have identical structure and polarity as well as identical intermolecular forces, so that there is no net change in these forces after solution formation, and during the formation of which there is no change in the enthalpy and volume. The enthalpy of mixing of the pure component for the formation of the solution is, that is, delta H mixing equals 0. This implies that heat is neither absorbed nor evolved during the mixing of components in a solution, and the volume of mixing of pure component for the formation of solution is also 0. That is, delta V mix equal to 0. Here, volume of entire solution equals sum of volume of the components. In the case of pure components, the intermolecular attractive interaction is of AA and BB type. In the case of binary solutions, the intermolecular attractive interaction is of AA, BB and AB type. Truly ideal solutions do not exist because there will be at least some difference in these characters of the components of any solutions. However, a number of solutions whose components are quite similar in their structure and polarity may be considered ideal for practical purpose. Some examples of such binary mixtures are solutions of N-hexane and N-heptane, solutions of bromoethane and chloroethane, and solutions of benzene and toluene. Another examples are ethylene chloride and ethylene bromide, and N-butyl chloride and N-butyl bromide. Non-ideal solutions or real solutions. A solution which does not obey Raoults law exactly under all conditions of temperature and concentration is called non-ideal solutions. It is a solution formed from components which differ in their structure and polarity as well as their molecular interactive forces. Delta H mixing and delta V mixing are not 0 because it is one during the formation of which there occurs change in enthalpy and volume. A binary solution deviates from ideal behavior if two components A and B differ in their characters. This is because in any such case, the presence of A molecules affects the escaping tendency of B molecules, and also B molecules affect the escaping tendency of A molecules. This is because the force between A molecules differ from those acting between B molecules. Next we are going to discuss about deviations from Raoults law. Liquid mixtures will deviate from ideal behavior if the components differ in their characters and intermolecular forces. This deviation may be either positive deviation or negative deviation. Positive deviation. If a solution is said to show positive deviation if the measured partial vapor pressure of the component as well as the total pressure are found to be greater than those expected from Raoults Law. And in such case, delta H mixing and delta V mixing will be positive. Thus, PA is the total pressure of component A is greater than P0A HA. HA is small fraction and P0 is the partial pressure of pure component. Similarly, PB is greater than P0B HB. In this case, the attractive force between solvent and solute molecules, that is AB, interactions are weaker than those between solute molecules, that is BB, or solvent molecules AA. The vapor pressure liquid composition curve for a system showing positive deviation is shown in this picture. And the dotted lines represents those for an ideal solution. The examples for systems showing positive deviations are ethyl alcohol and cyclohexane, acetone and carbon disulfide, ethanol and water, ethanol and benzene. Negative deviation. A solution is said to show negative deviation if the measured partial vapor pressure of the component as well as the total pressure are found to be less than those of expected from Raoults Law. That is, PA is less than P0A HA and PB is less than P0B HB. In such a case, the delta H mixing and delta V mixing will be negative. In such case, intermolecular attractive force between solvent-solvent, that is AA interaction, or solute-solute interaction, that is BB, is weaker than solute-solvent interaction, AB interactions. The vapor pressure liquid composition curve for a system showing negative deviation is shown in this picture. And the dotted curves are those for an ideal solution. Example, mixtures of phenol and aniline. In this case, the intermolecular hydrogen bonding between phenolic proton and lone pair on the nitrogen atom of aniline is stronger than the respective intermolecular hydrogen bonding between similar molecules. Example is mixtures of chloroform and acetone forms a negative deviation from Raoults Law. This is because chloroform molecule is able to form hydrogen bond with acetone molecule. Next we are going to discuss about azeotropes. Azeotropes are binary mixtures having the same composition in liquid and vapor phase and boils at constant temperature. It is impossible to separate the component by fractional distillation. Azeotropes are of two types: minimum boiling azeotrope and maximum boiling azeotrope. The solutions which shows large positive deviation from the Raoults Law is called minimum boiling azeotrope. Example, solution of ethanol and water on fractional distillation result in a solution containing approximately 95% by the volume of ethanol. And maximum boiling azeotrope. The solutions which shows large negative deviation from the Raoults Law is called maximum boiling azeotrope. Example, solution of nitric acid and water as approximately composition 68% nitric acid and 32% water by mass with a boiling point of 393.5 Kelvin. Colligative properties and determination of molar mass. We have learned that vapor pressure of solution decreases when non-volatile solute is added to volatile solvent. There are many properties of solutions which are connected with decrease of vapor pressure. These are relative lowering of vapor pressure of the solvent, depression of freezing point of the solvent, elevation of boiling point of the solvent, and osmotic pressure of the solution. All these properties depends upon the number of solute particles irrespective of their nature related to the total number of particles present in the solution. Such properties are called colligative properties. What is colligative property? Properties of dilute solution which depends only on the number of solute particles present in a given amount of solvent and not in any way upon the nature of solute particles are called colligative properties. All colligative properties are directly proportional to each other and also to the mole fraction of the solute in solution. And measurements of such colligative properties are important because they help in the determination of molar masses of the solutes. Relative lowering of vapor pressure. It is one of the colligative property. And what is lowering of vapor pressure? When a non-volatile solute is dissolved in a volatile solvent, the vapor pressure of the solvent gets reduced. The reason for this is if a solution contains non-volatile solute and the solvent is volatile, some areas of surface is occupied by the non-volatile solute molecules. From this occupied area, evaporation of the solvent is not possible. Thus, at constant temperature, the evaporation of the solvent from a solution is less as compared to that from pure solvent. Hence, the number of vapor molecules per unit volume is also correspondingly less above a solution than above the pure solvent. As a result, at a given temperature, the vapor pressure of a solution is less than that of pure solvent. Dilute solutions may be assumed to behave as ideal solutions. That is, they may be assumed to obey Raoults Law. And Raoults established that the lowering of vapor pressure depends only on the concentration of the solute particles and it is independent of their identity. According to Raoults Law, the relationship between vapor pressure of the solvent, mole fraction and vapor pressure of the solution is given by P1 equal H1 P10. When the solvent alone is volatile, there will be no contribution from solute towards the vapor pressure. Delta P1 is the lowering of vapor pressure. Delta P1 equals P10 minus P1, where P10 is the vapor pressure of pure solvent and P that of dilute solution of a non-volatile solute in it. Delta P1 equal P10 minus P1, or we can write delta P1 equals P10 minus H1 minus P10. Here the value of P1 is substituted. Thus we get this equation, which is equal to P10 into 1 minus H1. Because P10 is common. We know that H2 equal 1 minus H1 and replace 1 minus H1 as H2. Therefore, we get delta P1 equal P10 H2. In a solution contains several non-volatile solutes. The lowering of the vapor pressure depends on the sum of the mole fraction of different solutes. Then equation 2 can be written as delta P1 by P10 equals P10 minus P1 divided by P10, which is equal to H2. The ratio P10 minus P1 divided by P10 is known as relative lowering of vapor pressure. Thus, it is seen that for a dilute solution of non-volatile solute, the relative lowering of vapor pressure is equal to its small fraction of the solute in solution. H2 is the mole fraction of solute. We can write H2 equals N2 divided by N1 and N2, where N1 and N2 are number of moles of solute and solvent respectively. Then the equation becomes P10 minus P1 divided by P10 equals N2 divided by N1 plus N2. If N2 is very small than N1, we can neglect N2 from the denominator. Then the equation becomes P10 minus P1 divided by P10 equals N2 divided by N1. Or we can write this equation as P10 minus P1 divided by P10 equals W2 into M1 divided by M2 into W1, where W1 and W2 are the masses and M1 and M2 are the molar mass of solvent and solute respectively. The molar mass of solute, that is M2, can be calculated if other values are known by using this equation. I hope you might have understood what we learned today. We learned today about ideal solutions and non-ideal solutions. What is an ideal solution? An ideal solution which obeys Raoults law exactly at all temperatures and over entire range of concentrations. And the non-ideal solution which does not obey Raoults law. And the delta H mixing and delta V mixing is not 0. If in a solution the components have different characters and intermolecular forces, it shows two deviations, positive and negative deviation. Also, we learned about azeotropes. What are azeotropes? Azeotropes are binary solutions which have same composition in both liquid and vapor phase and are boiled at same temperature. There are two types of azeotropes. What are they? Minimum boiling azeotrope and maximum boiling azeotrope. Then we learn about colligative properties and discuss about one of the property.